You ever looked up at the night sky and wondered how rockets manage to soar into space? It's a fascinating question, especially when you realize that space has no air. If there's nothing to push against, what exactly propels a rocket forward? Today we'll unravel this mystery and explore the science behind rocket flight. We'll see how a simple rule of physics makes space travel possible and why rockets don't need air to move. Let's dive into the world of rockets and discover what makes them fly. One of the strangest things about space is that it's a vacuum. There's no air at all. On Earth, we're used to seeing planes and birds fly by pushing against the air, but rockets don't have that luxury in space. So how do they move? The answer lies in understanding the forces at play. Without air, rockets must rely on a different principle to propel themselves. This sets the stage for a fascinating journey into the science of motion and the clever engineering that makes space travel possible. Secret behind rocket flight is Newton's third law of motion. This law states for every action there is an equal and opposite reaction. It's a simple rule, but it has powerful consequences. When a rocket burns fuel, it creates hot gases that shoot out of the bottom. The action is the gases moving downward, the reaction is the rocket being pushed upward. This principle is at the heart of every rocket launch, whether it's heading to the moon or orbiting the Earth. Inside a rocket, a powerful reaction takes place. Fuel is burned, producing extremely hot gases. These gases are forced out of the rocket's engine at incredible speeds. The process is intense and creates a huge amount of energy. As the gases rush downward, they push the rocket upward with tremendous force. This is how rockets generate the power needed to escape Earth's gravity and travel into space. Force that pushes a rocket upward is called thrust. Thrust is created when the rocket's engines expel hot gases downward at high speed. The greater the speed and mass of the gases, the stronger the thrust. This force must be powerful enough to overcome gravity and lift the rocket off the ground. Thrust is the key to every rocket launch, and understanding it helps us see how rockets achieve their incredible journeys. Understand rocket thrust? Let's look at a simple example. A balloon. Imagine a balloon filled with air. When you let it go, the air rushes out and the balloon moves in the opposite direction. This is Newton's third law in action. The air escaping is the action and the balloon moving is the reaction. Rockets use the same principle but with much more power and precision. While balloons and rockets both use Newton's third law, rockets are far more powerful. Balloons rely on air pressure, but rockets use burning fuel and hot gases. The engines are designed to maximize thrust and control the direction of flight. This makes rockets capable of reaching incredible speeds and traveling vast distances, far beyond what a simple balloon can achieve. You might wonder how rockets work in space where there's no air. The answer is surprisingly simple. Rockets don't need air to operate. Unlike airplanes, which rely on air for lift, rockets carry everything they need with them. This includes both fuel and oxygen, allowing them to burn fuel and create thrust even in the vacuum of space. Rockets are specially designed to carry both fuel and oxygen. This is essential because, in space, there's no oxygen to support combustion. By bringing their own supply, rockets can burn fuel and generate thrust wherever they go. This clever engineering allows rockets to travel through the vacuum of space and reach distant planets and stars. Most rockets are built in stages. Each stage contains its own fuel and engines. As the rocket travels, it uses up fuel in the lower stages. Once a stage is empty, it's dropped off, making the rocket lighter. This process helps the rocket go faster and reach higher altitudes. Staging is a smart way to maximize efficiency and ensure successful space missions. As a rocket climbs higher, it sheds empty stages. This reduces weight and allows the remaining stages to accelerate more easily. The process is carefully timed and controlled to ensure the rocket stays on course. Dropping stages is a critical part of rocket design and helps achieve the speeds needed for space travel. At the start of every launch, rockets must overcome Earth's strong gravity. Gravity pulls everything toward the ground, so rockets need a huge amount of power to break free. This is why launches require so much energy and careful planning. Once a rocket escapes gravity, it can travel freely through space, exploring new worlds and possibilities. Rocket launches are dramatic and powerful events. Engines roar, flames burst out, and the rocket lifts off with incredible force. All this energy is needed to overcome gravity and reach space. Engineers carefully calculate the amount of fuel and thrust required for each mission, ensuring the rocket can achieve its goals. Once a rocket has enough speed, it escapes Earth's gravity and enters space. This moment marks the beginning of a new journey. The rocket can now travel freely, exploring planets, moons, and distant stars. Escaping gravity is a major milestone in every space mission, opening the door to endless possibilities. In space, rockets move forward by pushing gas backward. This simple idea is the foundation of space travel. Without air or resistance, rockets can reach incredible speeds and travel vast distances. The vacuum of space presents unique challenges, but rockets are designed to overcome them and achieve their missions. Science behind rocket flight is simple yet powerful. Newton's third law explains how action and reaction work together to create motion. By burning fuel and expelling gases, rockets harness this principle to travel through space. Understanding this science helps us appreciate the ingenuity of rocket design and the wonders of space exploration. Rocket engines are marvels of engineering. They are designed to burn fuel efficiently and produce maximum thrust. The engines must withstand extreme temperatures and pressures, ensuring the rocket can survive the harsh conditions of launch and space travel. Each engine is carefully tested and built to deliver reliable performance. The burning of fuel inside a rocket produces extremely hot gases. These gases are expelled at high speed, creating the thrust needed to lift the rocket. Managing the heat and pressure is a major challenge for engineers who use advanced materials and designs to keep the rocket safe and efficient. Controlling the direction of a rocket is crucial for successful missions. Rockets use fins, gimbals, and computer systems to steer and stay on course. By adjusting the angle of the engines, rockets can change direction and reach their intended targets. Precise control is essential for landing on planets, docking with space stations, and exploring the universe. Space is a harsh environment with no air, extreme temperatures, and radiation. Rockets must be designed to survive these conditions. Engineers use special materials and insulation to protect the rocket and its payload. Overcoming the challenges of the vacuum is a key part of every space mission. Rockets carry payloads such as satellites, scientific instruments, and astronauts. The payload is carefully protected and delivered to its destination. Each mission is designed to achieve specific goals, from exploring distant planets to studying Earth's atmosphere. Payloads are the reason rockets are launched, and their success depends on precise engineering. Rocket technology has opened the door to space exploration. We can now send probes to distant planets, land on the moon, and study the universe. Each mission builds on the science of rocket flight, using Newton's third law and advanced engineering to reach new frontiers. Space exploration inspires curiosity and drives innovation. Rockets have made it possible to land humans on the moon. The Apollo missions used powerful rockets to escape Earth's gravity and travel to our nearest neighbor. These historic journeys showcase the power of rocket science and inspired generations to dream of exploring space. Rockets are now being used to explore Mars. Robotic probes and rovers have landed on the Red Planet, sending back valuable data. Future missions aim to send humans to Mars using advanced rockets and technology. The journey to Mars is a testament to the power of science and engineering. Rockets are used to launch satellites into orbit around Earth. These satellites provide communication, weather data, and scientific information. Each launch requires careful planning and precise engineering to ensure the satellite reaches its intended orbit and functions correctly. Rockets deliver supplies and astronauts to the International Space Station. The station orbits Earth and serves as a hub for scientific research and international cooperation. Rockets make it possible to maintain and expand the station, supporting ongoing missions and discoveries. Rocket technology is now enabling space tourism. Private companies are developing rockets to carry passengers into space. This new frontier offers exciting opportunities for adventure and exploration, making space accessible to more people than ever before. Modern rockets are being designed to be reusable. This means they can return to Earth, be refurbished, and launched again. Reusable rockets reduce costs and make space travel more sustainable. Innovations in engineering are making this possible, changing the future of space exploration. Safety is a top priority in rocket design. Engineers use advanced systems to monitor and control every aspect of the launch. Emergency procedures are in place to protect astronauts and equipment. Careful planning and testing ensure that rockets can perform safely and reliably. Rockets are built from strong, lightweight materials. These materials must withstand extreme heat, pressure, and vibration. Engineers use metals, composites, and insulation to create rockets that are both durable and efficient. Material science is a key part of rocket development. Before launch, rockets undergo rigorous testing. Engines are fired, systems are checked, and every component is inspected. Testing ensures that the rocket will perform as expected and helps identify any issues before the mission begins. This careful process is essential for successful space travel. Every rocket launch is carefully planned. Engineers calculate the trajectory, fuel requirements, and timing. Mission planning ensures that the rocket will reach its destination and achieve its goals. This process involves teamwork, precision, and a deep understanding of science and technology. Rockets are launched from special sites called spaceports. These locations are chosen for their safety, accessibility, and proximity to the equator. Launch sites are equipped with advanced technology and support systems to ensure successful missions. Space agencies like NASA, ESA, and others play a vital role in rocket development and space exploration. They design missions, build rockets, and collaborate internationally. Their work advances science and inspires people around the world. The history of rockets is full of innovation and discovery. Early rockets were simple, but over time, engineers developed more powerful and efficient designs. Today's rockets are the result of decades of research and experimentation, making space travel possible for humanity. The future of rocket technology is bright. Engineers are developing new engines, materials, and designs to make rockets faster, safer, and more efficient. Future missions will explore deeper into space, reaching new planets and expanding our understanding of the universe. Rocket science has a huge impact on our lives. It drives innovation in materials, engineering, and technology. The discoveries made through space missions benefit many fields, from medicine to communications. Rocket science inspires future generations to dream big and reach for the stars. Building and launching rockets requires teamwork. Scientists, engineers, and technicians work together to solve complex problems and achieve mission goals. Collaboration is essential for success, and every launch is a testament to human ingenuity and cooperation. Communication is vital during rocket launches. Ground teams monitor the rocket's progress, send commands, and receive data. Advanced systems ensure that information flows smoothly, supporting safe and successful missions. Navigating rockets through space requires precision. Computers calculate trajectories, adjust course, and ensure the rocket reaches its destination. Navigation systems are critical for landing on planets, docking with stations, and exploring the universe. Rockets collect and transmit valuable data during missions. Sensors monitor conditions, record information, and send it back to Earth. This data helps scientists learn more about space, planets, and the universe, advancing our knowledge and understanding. Innovation is at the heart of rocket science. Engineers constantly develop new technologies, improve designs, and solve challenges. Each breakthrough brings us closer to exploring new worlds and understanding the universe. Rockets inspire people around the world. They represent the spirit of exploration, curiosity, and discovery. Watching a rocket launch reminds us of what's possible when we dream big and work together to achieve great things. The possibilities of space travel are endless. Rockets make it possible to explore new worlds, study distant stars, and unlock the secrets of the universe. Each mission expands our horizons and inspires us to keep reaching for the unknown. Summary: rockets move forward by pushing gas backward, thanks to Newton's third law of motion. They carry their own fuel and oxygen, allowing them to travel through the vacuum of space. Staging, powerful engines, and advanced technology make space exploration possible. The science is simple, but the engineering is complex and inspiring. Rockets have changed our world and opened the door to the universe.